Hey 8th graders, thanks for tuning in. This lesson is on is that relation linear? Basically, it's looking at a table and seeing if it's going to plot a straight line if I put it on a graph. But instead of putting it on a graph, what we're going to do is we're going to calculate each set of ordered pairs using the slope formula. So if you went on Miss Beatley's classroom and opened the notes, you should have received these. These are the steps that we're going to follow. We're going to calculate the rate of change from all points listed in the table using the slope formula. Then what we're going to do, if all the rate of change is the same, it's going to represent a straight line. Because what that means is the graph is either increasing or decreasing at the same rate. If they are not the same, we can determine that it is not going to be a straight line because the rate of change is not increasing nor decreasing at the same rate. So let's go ahead and get started. Let's remember that we're going to use our slope formula, which is indicated here. And the teacher example that I'm going to use in the classroom, so just in case you were absent, this should be in your reference book right after rate of change from a table. Now the one thing we want to do is we want to look at how many sets of ordered pairs are in this table. In this case, we have 4 sets. That means we always check one less than the sets. We're going to have to check 3 sets. This will be my first set. That marker's not working. This will be my first set. This will be my second set of ordered pairs. And this will be my third set. That's how you know how many sets is looking at how many sets of ordered pairs and using one less. Remember, our ordered pairs are indicated by X, Y. That's our x-axis as we're graphing a point, and then we're going up on or down in our y-axis. My first check, I'm going to indicate by using a 1. That way we know what check we used. And my ordered pairs for that is, the first one is 2, 14. My second set in my first one is 5, 35. To calculate this, if we remember to use this formula, we need to label our sets using our ordered pair format as X and Y. But this is my first set, so I'm going to label it as X1, Y1. So if that's my first set, this will be my second set, which is X2 and Y1. Sorry, Y2. Now what I'm going to do is I'm going to put in the formula. I'm just going to follow this. Y2 is 35. And my Y1 here is minus 14. Over my X2, which is 5, minus my X1, which is 2. So we're going to do the subtraction here. 35 minus 14 is 21. And that will be over 5 minus 2, which is 3. That is my rate of change. But I can also reduce this because it's a common factor. I know 3 can go into 21 7 times. 3 goes into 3 1 time. You always want to reduce. That way, if you reduce to the simplest form, it's really easy to see if the rate of change is the same. Now I'm going to go ahead and check my second set, and I'm going to indicate this as 2. Let's see. I'll use a different color. This line indicates that I'm using this ordered pair, which is 5, 35. And then the second set is 7, 49. Don't forget we need to label them again. X1, Y1, X2, Y2. I'm going to place it in the formula again. y2 is 49 minus y1, which is 35, over x2, which is 7, minus x1, which is 5. And then I'm going to do the simple subtraction here. 49 minus 35 is 14, and 7 minus 5 is 2. Remember when I was just at this problem where I said 21 over 3 to make sure you reduce it? If I looked at 21 over 3 and 14 over 2, I would assume they are not the same. But if I reduce 14 over 2 by dividing by 2, because 2 can go into 14 7 times, and 2 can go into 2 1 time, I can actually see that these are the same. So always reduce, reduce, reduce. I'm going to put an arrow here and write reduce. You want to make sure you remember that. All right, last check. Remember, we have 3 checks. Okay, let's see if this pink shows up. Nope, we'll go back to black. So number 3, I'm going to use the ones that I indicated for 3. And I'm going to have 7, 49. And I'm going to have 10, 70. I'm going to label these as x1, y1, x2, y2. Back to my formula. I'm going to put 70 as my y2 minus 49 as my y1. This is going to be over 10, which is my x2, minus my x1, which is 7. Let's go ahead and do that subtraction. 70 minus 49 is 21. And 10 minus 7 is 3. One more quick reminder. If I had just left these, I would have said this was not a relation because these two are equal, but this one is not. But that is incorrect because I did not reduce. 3 goes into 21 equally 7 times, and then 3 goes into 3 1 time. If I look to the right, I can see all 3's checks come out as the same rate of change as 7 over 1. So in this case, I can say that this will form a straight line because the rate is the same of 7 over 1. Okay, not only did I show each set, I also explained my reasoning. Make sure you have each step in the book. You must check each one. If the first 2 come out correct, you don't know if the third one will. Do not just assume, always check. Alright, so the last example I'm going to give is the one from classwork, and it's problem 3 on page 157. If you don't have it out, pause the video, go ahead and pull it out of your 3-ring binder, or if you were absent, you can open it up under Thursday on Miss Beatley's classroom. Go ahead and log into either Math 8 or Honors. As always, go ahead and read exactly what the problem wants you to do so you don't do more than you need to. In this one, it says if the rate of change between every pair of ordered pairs in the table of value is the same or constant, then the ordered pairs, when plotted, will form a straight line. That's key. The key is that we need to make sure each set in the table is going to be the same rate of change to be able to form a straight line. We're not graphing these, so what we're actually doing is we're checking to be sure it's going to form a straight line. So right here in part 1, it says calculate the rate of change between the points represented by the given order pair. Just a quick reminder, you want to count how many are in your table to see how many pairs. There are 4, so I know there's going to be 3 sets of checks. Luckily, in your book, A, B, and C indicates the pairs you're going to be checking. So for this one, I'm going to just do X1, Y1, X2, Y2. Same thing, I'm going to label them all the same just to represent what's my first pair and my second pair. In the classwork tutorial, I'm going to go slightly faster just to show you how it's done. So my Y2 is 28. And I'm going to do 28 minus my Y1, which is 13. My X2, which is 9, minus 4. This is going to equal 15 over 5. But remember, you always want to reduce because you want to be able to see. 5 goes into these equally. If I divide, 5 goes into 5 one time. 5 goes into 15 3 times. My rate of change for the first one is 3 over 1. My next set, I'm going to do 34, which is my Y2, minus 28, which is my Y1, and 11 minus 9, which is my X2 minus X1. When I do 34 minus 28, I'm going to get 6. 11 minus 9 is 3. Okay? Just double check. I'm sorry, this is actually 2. 2 goes into 6 3 times. 2 goes into 1 time. In this case, it is also 3 over 1, but you can't be fooled. You must check the third one to see if it's going to form a straight line because all 3 need to equally fit. In this case, I'm going to get 47 minus 34 and 16 minus 11. 47 minus 34 is 13. 16 minus 11 is 5. Well, we know we have 2 prime numbers here, so it cannot be reduced. This goes back to what I originally said. You must check all checks. Because if I just stopped at the first 2, I would have wrote that it was a linear. The relation was linear. In this case, it's not. Because the third check comes out as a different rate. So, let's do D. Will the ordered pairs listed in the table form a straight line when plotted? Okay, we're going to put we're going to explain our reasoning. The ordered pairs will not is a key word, okay, we're going to underline that, form a straight line when plotted. Here comes our reasoning. Because the rate of change are not the same. These are a little time consuming, but you want to make sure you check all. Good luck with this. Be sure that you click on and you get all the Carnegie pages and have those all for the next day you return. Okay? Thank you. Thanks for tuning in. Make sure your reference book is updated and you have all these set and clear.